I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we are discussing a very important test question based on modeling of sinusoidal functions. So here is a real life situation. I am treating this as a challenge question since it is one of the most difficult questions which students come across while they do modeling with trigonometric functions. Mainly the reason is the wordings in the particular question which is just before you. I'd like you to pause the video, read the question, answer, and then look into my suggestions. The question here is a train engine is going around a circular track that is zero point 0.6 kilometer in radius. It starts across the ring from the platform, which is zero point 0.2 kilometers outside the ring, and is intercepted at an angle of 37 pi by 4 after riding for 20 minutes. You need to find the time for the train engine to complete one round in minutes. Write a sinusoidal function to model distance of engine from the platform. And 3. Find engine's distance after 10 minutes of the ride. So this distance is distance from the platform. The sketch given here gives you the round track where the engine is moving, and this strip indicates the platform. We need to model the position of engine from that of the platform. So the distance between these two at any instance of time. That's the whole thing. So let's try to understand the question. First is we need to find the time for train engine to complete one revolution. The statement which relates to the revolution is that the intercepted at an angle of 37 pi by 4 after riding 20 minutes. So we'll use after riding of the engine over the track, correct? So basically that becomes the total angle covered in 20 minutes. That should give you the time for one revolution. So I hope that is clear to you, right? So take this as a hint and then answer this question. Now let me share with you my suggestion on this particular thing. So what we are given here is that a train engine is going around a circular track that is zero point 0.6 kilometers. Let us say circular track, this being the center, zero point 0.6 kilometers in radius. So it is 0.6 in radius, correct? So that 0.2 kilometer outside the ring is the platform. So this is the platform for us, which is 0.2 kilometers. So as you can see, the axis here is at 0.8 kilometers, correct? Now, that is the situation. However, what are we interested now in finding is time for one revolution. How are you going to find this time? So when we say that is intercepted at an angle of 37 pi by 4 after riding for 20 minutes, it really means that let's say the engine is going around, right? So the angle in radius made by the engine is 37 pi by 4 in 20 minutes. Now that should give you the time period. So it is in radius. So many radians in 20 minutes. We will now find the time for one revolution. So let t be time for one revolution, right? T is time for one revolution. So when I say one revolution, it means what? It means 2 pi radians. So time for 2 pi radians is what we need to find. You get the idea. We already know that for 37.5, 37, let's write pi by 4, radians is in 20 minutes. So 1 radian will be in how much? Well, 1 radian will be in 27 divided by this, which means 4 by pi times 1 over 37, correct? So many minutes will get 1 radian. However, 1 full circle is 2 pi radians. So 2 pi radians in how much time? So that will be in, we can multiply this by 2 pi, right? So we get 20 times 4 over 37 pi times 2 pi, correct? So that is how you can get time for 1 full revolution, which is basically 2 pi radians, right? So we can cancel and simplify a bit, and that gives you the answer as what? 20 times 4 is 80, 80 times 2 is 160, right? 160 over 37 minutes. So that is the time for 1 revolution, and therefore we have the first answer, which is that the time period t should be equal to 160 over 37 minutes. Is that clear? Perfect. So we have clearly, using unitary method, found how much time does it take for 1 revolution, and which is the time period. Okay, so the first part is done for us. Let's look into the question. We have found this time, which is t equals to how much? 160 by 37 minutes. Now the second part is write a sinusoidal function to model distance of the engine from the platform. So now let's try to do this. Okay, so here is what we did just now. That is, t is the time for 1 revolution, which is 2 pi radians, which we need to figure out. We know 37 pi by 4 radians in 20 minutes. 1 radian will be 20 divided by 37 pi by 4, which gives us 80 over 37 pi in minutes. 2 pi radians, we'll multiply that by 2 pi, giving us the time of 160 divided by 37 per minute. So, time period for 1 revolution is 160 over 37. Correct? Okay, so let's move forward to model. So now we just calculated that the time period for 1 revolution is 160 over 37 minutes. We need to now model the situation. So let's try to understand. It says a train engine is going around a circular track that is 0.6 kilometers in radius. It starts across the ring from the platform. So this is the platform. Do you see that? Across the ring means directly across. Let's say that is the position. So it is at the maximum distance. Do you see that? So that becomes the maximum distance which the engine is at. Assuming it's moving in this particular direction, it is moving in the counterclockwise direction, which is taken as positive. Assuming that's moving, assuming that it is moving in counterclockwise direction, and that is the maximum distance from the platform. We need to model the distance from the platform at any instance of time, time being measured in minutes. So what are we given here? We are given that the radius is 0.6 kilometers, right? So this is 0.6 and that is also 0.6. And the circular path is 0.2 kilometers away from the platform. So that is 0.2. Do you see that? So from here, we can work out the axis. So that becomes the axis. This is your minimum distance from the platform, and that is your maximum distance from the platform. Correct? You're starting from the maximum, so you can say that the sine wave will be kind of like this. So it is a cosine wave without any phase shift, starting with the maximum. So now, since it is a cosine wave, why not model as a cosine wave? So we can say that the distance basically with time is equal to amplitude. Now, amplitude in this particular case is going to be what? Is going to be the radius, which is 0.6. So in general, let me write this as A cos of kt plus axis, let's say q, where q is this distance from the platform we are taking. So it will be from the platform. So from here, right? That is q for us. Axis. A is the amplitude, which is same as the radius. So we know that in this case, the radius is going to be 0.6, which is in kilometers. So let's convert that to meters, right? So radius of 0.6 kilometer can be written as 600 meters, and that initial distance, which is 0.2 kilometers, will be 200 meters, correct? So that is the minimum distance away from the platform. So in this case, A is going to be the amplitude, which is 600, we are writing in meters, cos of kt. How do you find k? Well, k is basically equal to 2 pi by t. And we know what t is. T is 160 over 37. So it is 2 pi over 160 over 37, correct? So that becomes the value of k, which I can always write as equal to 2 pi times 37 over 160, correct? Simplifying, cancelling 2 with this as 80, I can write this as 37 pi by 80. Does it make sense to you? Correct? So that is how I can get the value of k. So the calculation shows here indicates that the k value is 37 pi by 80. Clear? So I'm writing k as 37 pi by 80 times t, of course, no phase shift since we are starting from the maximum. And the value of q is 0.6 plus 0.2, which is 800, correct? So that is the axis. So we can add 0.6 to 0.2 to get the distance from the platform. So that becomes the distance, and the units will be in meters. So that is how you could actually model the situation. Is that clear to you? Correct? Now let's look into the solution for the question. So we have got this model. Now, part 3 is to find the distance after 10 minutes. So in that case, I'll substitute 10 here. So distance after 10 minutes will be 600 cos of, this is 37, I wrote, 37 pi times 10, correct, over 80 plus 800. So that we can calculate to find the distance in meters. Is this concept clear to you? So we answered part B and C also. Perfect. So here is your complete solution of part B and C. We know that we are modeling this situation keeping the engine at farthest away. That means we are looking into the cosine wave, which is in this fashion, correct? Where the distance, that is the axis, and this is the maximum distance, correct? So as you can see that the maximum distance will be what? Let me write in meters: 600, 600 and 200. Axis being 800, right? And the amplitude being 600. The time period has already been calculated, which is given to us as 160 by, so t is equal to 160 by 37. So we can now find the function height or the distance away from the platform is a cos kt plus q. T is 160 over 37 in minutes. So k is 2 pi by t, which gives us 2 pi times 37 by 360, cancelling 2 and getting 80 in the denominator gives us 37 pi by 80 for the value of k. Amplitude being the radius, zero point 0.6 kilometer, written as 600 meters, q being the axis, which is sum of 600 and 200, right? So add them up, you get 800. So the height or the distance away from the platform is 600 cos 37 pi 80 t plus 800 as given here. Part B is to find what happens when t is 10 minutes. So when t equals to 10 minutes, in that case, substitute 10 for time t and calculate using the calculator. What we get is 570.38 meters rounded to 570 meters. Perfect. So that is how we are going to solve this particular question. So I hope the concept is absolutely clear. So the idea here is to understand the situation. We are starting with the train engine on the far end. We are given the radius and the distance from the platform. We have to model the distance from the platform of the engine, right? So it is any horizontal distance which we are looking into. You get the idea. Which basically can be modeled with a cosine function, right? Where it starts with the maximum and then it moves in periodic way as shown here. Taking cosine function is good because the phase shift is zero. So I hope this strategy helps. Thanks for your time and all the best.